Good afternoon. Hello, everyone, and thank you for joining us today. I'm Rachel Patton, Executive Director of Preserve Arkansas. Preserve Arkansas is the statewide nonprofit advocate for historic preservation. Welcome to Women in Preservation, the series that features women who are working to save historic places. Thank you to our series sponsor, DMX Architecture of Fayetteville, for their generous support of women in preservation. Many of you are already members of Preserve Arkansas, and we thank you for your support. If you're not already a member, I'd like to formally invite you to join us for as little as $50 a year. Your memberships provide vital support to our organization and allow us to continue the important work of saving Arkansas's historic places. You can learn more and join at preservearkansas.org. Our Ramble is coming up on November the 4th. Preserve Arkansas Rambles are bus trips to different parts of the state that explore Arkansas's heritage sites for an exceptional experience filled with history and fun. Our 2023 Ramble will transport guests from North Little Rock to Northeast Arkansas, where they will enjoy tours of historic places along the Great River Road from Marion to Blytheville. Tickets are available on our website at preservearkansas.org. And you are invited to join us for our annual membership meeting on November the 16th at the Art Space on Main in downtown Pine Bluff. This event is free for Preserve Arkansas members, and you may RSVP on our website at preservearkansas.org. Join us for our next Women in Preservation talk on November the 14th, featuring Jill Judy, co-owner of Downtown Dwellings in Little Rock. Now it's my pleasure to introduce today's speaker, Lori Ferriss. Lori Ferriss is an architect, structural engineer, and preservationist focused at the intersections of building reuse and climate action. She is a co-developer of the CARE tool, which estimates the carbon benefits of reusing and retrofitting buildings. And her research in establishing carbon accounting methods and standards of practice for existing and historic buildings has been featured in publications ranging from the Journal of Architectural Conservation to Architect Magazine, and presented on stage at the United Nations COP27 Climate Conference. Lori is the 2023 chair of the AIA Committee on the Environment, a steering committee representative for the Climate Heritage Network, and a senior fellow of Architecture 2030. Welcome, Lori.
Thanks, Rachel. Thanks so much for having me today. I'm just going to share my screen. All right. Play my slides. All righty. Yeah, so I'm going to try and spend the next 40 minutes or so talking about, my path, what motivates me to be here, and how I got to where I am, with some little episodes into work that I think has been really important along my career journey and pushed me in one direction or another, and what makes me feel like I'm having an impact. So firstly, just about me, this is my daughter and my husband. I have a 5-year-old, and I think she's been a huge motivator and really shifted the way I think about my work, and kind of given me a whole new appreciation for the concept of stewardship and why protecting and preserving what we have for the next generation really matters, and what thinking about what we're really leaving behind for the next generation. I've lived all over. I'm originally from Louisiana, not too far from Arkansas. Born in New Orleans, I spent quite a bit of my childhood in Lafayette, a brief stint in Tucson, Arizona, and then Asheville, North Carolina for high school, and then up to Boston, where I've been since I came here for college. I've also taken a bit of a circuitous route, and I'll talk a little bit about this journey in the following slides, but essentially I went to school for architecture, and I'll tell you why in a minute. I got my bachelor's of science in architecture. I then went into a master's of engineering in structures. I pivoted into engineering. I worked as an engineer out of college, doing structural engineering as well as preservation engineering with Silman, which was at that point Robert Silman Associates. I wanted to do more preservation, so I went to Building Conservation Associates, where I did purely preservation consulting for a few years. And then I really wanted to come back out to the big picture, which led me to Goody Clancy, where I did architecture, preservation, and sustainability until this summer. And I am now doing a research and teaching fellowship at the School of Architecture at Northeastern University, where I really get to dig in and explore some of the topics I'm passionate about. I'm also doing business consulting for AEC firms and companies through the Cameron McAllister Group, as well as some independent consulting. So I'm at a stage in my career where I'm kind of sampling all of the different ways to really pursue work that I think is meaningful. So I just want to start with a little bit about how I got, what motivated me to go into this field. And it was really about a childhood that was rooted in place and this intrinsic relationship between environmental and cultural stewardship. So that's me as a little kid, same curly hair. This is New Orleans in City Park. You can see the beautiful live oak, which was part of the landscape in which I grew up. And growing up in Southern Louisiana, you really understand this relationship between the built environment and the natural environment just as a given. In school, in elementary school, we grew up learning about the Mississippi River and how naturally over time its path winds and changes based on its natural evolution. But because of human settlement, we locked it into place. And so in order to make our own spaces permanent, we fixed this. We've tried to control and fix the natural phenomenon of the Mississippi River, obviously to great impact. We've used engineering solutions like levees, which we know have failed over and over again, leading to severe loss of life and property. But flooding, this relationship of living in a place with hurricanes, living in a place in the flood zone, adjacent to rivers, adjacent to the bayou, this was just part of life. And it was kind of an understood relationship with the culture, and the sense of place and the sense of identity was tied to the sense of the natural environment around you. And this is the architecture that came out of that relationship. So this is Vermilionville in Lafayette, where I spent a lot of time as a kid. I loved to visit. I loved the people in period costume, learning to spin, learning to card wool and spin it into yarn, and going to the dances and everything. But this is a vernacular architecture that speaks to place and environment and culture. It has overhangs to shelter from the sun. It has shingles that can expand and contract with humidity to really provide natural ventilation that's appropriate to the outside climate. Operable shutters that block solar heat gains. All of the passive performance strategies, of course, made out of local materials. So this was, for me, what really got me into the built environment. And it wasn't just in Louisiana. We traveled a lot, and I've always just been fascinated by the way that the way that we build our spaces around us, and the way that these spaces that we construct talk about who the people were who built them and what the time, when they lived, what was available to them. So for example, Mesa Verde, a very different architecture from that of Louisiana, but understanding how the Native Americans there used the mountains and the cliffs and the earth around them to build these structures that have thermal mass and are protected from the heat and the sun of the desert. And the American Museum of Natural History, which is a beautiful place that inspires awe. So just the ability of buildings and architecture around us to create this sense of place and feeling and culture and excitement. It really motivated me to understand how I could be part of that. So I went to school for architecture. I came up to MIT, where our classes were right behind the words Massachusetts Institute of Technology here in the architecture department. And I really focused on building technology and tried to make it as much about architecture history as possible. So for my thesis in my architecture education, I studied the earliest wrought iron trusses in the United States in a gatehouse outside of Boston. This was my first foray into architectural research. And I was really, interested by the craft of these historic trusses. They were kind of at a transitional period when we were moving from wood into iron, into steel. I started doing some structural analysis, and I made my first set of preservation recommendations. So after this degree, I realized that more than design, I really wanted to focus on how buildings work, and especially existing in historic buildings, and what we could learn from them to apply both to preservation and to new buildings. So I went from my architecture degree into a master's of structural engineering, where ironically, I wrote my thesis about sustainability as a lead for historic preservation. So I got my engineering thesis done in my architecture degree. I came back and I really wanted to hear focus on inherently sustainable features and understanding how the way that the design industry of the time recognized sustainable design was sort of divergent from concepts of preservation, even though we know that preservation and most historical buildings, especially those constructed before the Industrial Revolution, are inherently better performing than most of what we build today. So from there, I really wanted to focus on preservation and really just get my hands on old buildings and historically significant buildings. So I went to work for Silman, which is an amazing company. Bob Silman was truly a leader and at the vanguard of oh, my slides are auto advancing. At the vanguard of preservation engineering. So I got to work with structures like stabilizing the ruins at this Quaker barn on the left, all the way to really high touch buildings like the Renzo piano renovation to the Harvard Art Museums, and understand how existing buildings perform, how historic materials perform, and how we can intervene to stabilize them, to modernize them, but really getting to understand what we already have. I did a wide range of work at Silman, not just historic buildings, but also new construction like the Grace Farms complex by Sana on the right. I did some high-end residential, which is, totally different. And then things like, for example, these Christmas lights display on historic facades in Manhattan. So I really had to experience quite a range. Sorry, I'm gonna have to turn off my timings. Sorry about that. I don't know. Okay. I don't know why that's happening. Okay, sorry. Back to the show. So from Silman, as you saw, I was doing this wide range, and what I really, really wanted to do was preservation. I wanted to do all preservation. So I moved over to Building Conservation Associates, which does that. They do only that. They work on historic buildings, recommending treatments, recommending preservation approaches, guidelines, and really doing some innovative work. So in that job, I worked on things ranging from the Boston Customs House to this tower on the left, which is 177 Huntington Ave in Boston. It's the tower designed by I.M. Pei as part of the Christian Science Plaza here. In the middle, you can see me standing on the mast climber 300 feet up in the air. I'm really scared of heights. So it turns out that this was not the job for me, spending most of my time up doing hands-on survey and hands-on construction monitoring on historic buildings. But I did get to experience a lot of the really important heritage that we have in Boston. And what I learned from this is that, well, I'm gonna get to that in a minute. One project I worked on at Building Conservation Associates, the last big project I work on that was really, I think, impactful to my direction was a small consulting job to support the first Keeping History Above Water conference in Newport, Rhode Island. So for those of you who aren't familiar with Keeping History Above Water, it's a really, it's been an amazing effort that is all about rising sea levels, extreme rain events, and what that means for our built heritage. And the first one was held in Newport, and it was really motivated by this building, 74 Bridge Street. So this is a historic building from 1725, built in the Point neighborhood. This is the oldest neighborhood in Newport, Rhode Island, which is in itself a very historic neighborhood, known mostly for its Gilded Age summer homes, its cottages. But this is a much older neighborhood that was built by pretty wealthy, affluent craftspeople. So this was the Townsend House, built in 1725 for a furniture maker. And you can see here that this neighborhood is extremely vulnerable, both to sea level rise, but also to heavy rainfall because of how the city has developed around it. So the question here was, how can we, the Newport Restoration Foundation, which owned the house at the time, how can they, explore how to make this building resilient for the future, for a changing climate, and to use it as a model to really kind of help answer this question and bring together experts on this topic for all historic places that are at risk due to this type of climate change. So you can see here on the left, this is the neighborhood we're talking about. It's right on the water, and you can kind of see these hurricane inundation scenarios where with even a Category 1 hurricane, much of this neighborhood is projected to be inundated by water. And you can see on the right, this is an elevation, the main elevation of that house of 74 Bridge Street. And this is not just a question of performance, it's a question of code compliance and of insurance. So there are a lot of nuances here, but essentially you can see that mean high water is just below the surface here. It's just under the ground. Hurricane Sandy did flood this house. It came right up above the threshold and came into the building and flooded the first floor. And then code compliance, this 13-foot NAVD is FEMA's requirement. And so you can see that in order for this building to be FEMA compliant, you would have to elevate it almost an entire story. So this obviously raises huge preservation questions around authenticity and reversibility and how we address resilience in buildings like this. So part of what I did was, look at where the water was actually projected to be. This is one of the questions is just around the uncertainty of climate. So on the left, you could see this, projected high water point by 2016 when I did the project. And on the right, you can see estimates by the year 2100. And this isn't even the craziest estimate. This is sort of an average. Where do we think water is going to be in a combination of hurricane and high tide? So you can see that this is really a problem, that in order to preserve these buildings, they have to change. We can't think about preservation as just keeping them the way they were, because they will disappear if we do that. So we explored a number of approaches to flood proof, and really we were focused because of this uncertainty in the long term, and the fact that the building scale interventions really have to be paired with utility scale interventions. What's the city going to be doing about managing floodwaters? Are there going to be barriers? How are they going to make sure that water drains away from these streets, et cetera? So we kind of focused on near-term solutions that were appropriate, we felt, for the heritage, which included filling the basement, ventilating the crawl space so that you could have wet floodproofing so that water that came through could dry out without damaging the building. And in fact, wet floodproofing kind of highlights the inherent resilience benefits of historic buildings, because these buildings were made with lime plaster and wood, wood that can kind of absorb and dry out a few times without being too deteriorated. These materials are actually more resilient to flooding than what we would put in now, like drywall, which would have to be ripped out. We did, the basic easy things like grading, and we did talk about elevation because the wing the kitchen addition to the house, which is not original, is even lower than the main house. So we talked about lifting that part of the house up because it was the most vulnerable. And what we ended up doing was kind of recommending this whole combination of strategies as a near-term, mostly reversible impact approach to the building, so that if something like elevation, which is a really dramatic intervention, it's hard to know how to take a really big intervention when you don't know what the codes will be, what the projections will be for flooding. So we decided on a more minimal intervention to start with that will protect the building until there are more knowns at the municipal and the neighborhood scale and related to insurance. So this project got me really excited about how our historic buildings are going to face the changing climate around us. And I realized that I wanted to do more of this. I didn't just want to conserve buildings. I really wanted to understand how we're going to use them in the future, how they're going to remain viable, how they're going to remain functional and durable. And so that brought me back to architecture, where I could really have a more holistic view of the work I was doing. And I came to Goody Clancy to work with Jean Caroon, who would be mortified to see her picture in my slides. But Jean Caroon, for those of you who don't know, is a real pioneer of sustainable preservation. She wrote the book Sustainable Preservation, and has been at the forefront for decades, talking about how inherently sustainable our existing buildings are and how imperative it is that we reuse them. So at Goody Clancy, I was drawn, to the range of work done there. For example, on the top right is the St. Elizabeth's West campus, which is a National Historic Landmark in DC. On the bottom is a residence hall at Mount Holyoke College, completely different era, but a lot of historic buildings, all with different use types and different constraints and requirements. So that was really exciting for me to just kind of experience a whole breadth of buildings, and not just how we preserve them, but why we preserve them and what's going in them and who's going to use them and how are they maintaining them and all these other questions. So I'm going to pause here because what really motivated my next my next stage of growth was this concept that building reuse is climate action. I'm going to do a little technical diversion. Try not to get too I'll try not to be too nerdy about it. But just to backtrack on this concept, going back to the Paris Agreement of 2015, the parties of the world agreed that in order to avert the worst of global warming, we needed to cap global temperature rise to somewhere between 1.5 and 2 degrees Celsius. So that was the commitment made at the Paris Agreement. We know from all of the science since then that we're nowhere near meeting this target. We know that we're now projecting to well exceed 2 degrees Celsius, and the higher ranges are going up to 8+ degrees Celsius. So we really need to make changes in the very near term. We don't have the luxury of thinking about how do we reduce emissions over the next 20 years. We have to reduce emissions right now. And so when we think about what this means sort of tactically, we have a carbon budget, and in order to meet that carbon budget, we need to reduce our emissions by at least 50 to 65% by the year 2030. So again, this is not looking at over the lifespan of a building, it's looking at right now in the next decade. And we know that buildings are responsible for a huge percentage of emissions. Globally, that's about 40%. In urban areas like where I am in Boston, it's closer to 70% of our emissions coming from buildings. But of those emissions from buildings, about 28% are from operating buildings. So this is heating, cooling, lighting, plug loads, whatever it takes to run a building. Those are the operational emissions. And these are coming from existing buildings that are using energy. The other 11% are what we call embodied carbon emissions. And those embodied emissions are essentially environmental impact that results from extracting materials, mining them, bringing them to a manufacturing facility, processing them, transporting them to a construction site, and then building a building. And then what happens at the end of life is it demolished and sent to a landfill. So this is the other 11%, and that's mostly new construction. And so when we talk about reusing buildings and the positive impact that can have, it's really a double whammy, because we can both reduce the operational emissions by making buildings more efficient, and we can reduce the embodied emissions by avoiding all the material that goes into new construction. And I'm going to talk a lot about carbon because it's the metric that people typically use, but there are obviously many, many impacts to material use. For example, material resource extraction is the primary cause of biodiversity loss. And here in the United States, 75% of our raw material extraction feeds the construction industry. So it's really, it's really non-negligible. And we also know, as we saw from 74 Bridge Street, and as we see all around us, that our heritage, it's not just what benefit can our heritage offer in terms of climate mitigation, but it's also how vulnerable is our built heritage. We know that we're already losing historic places to climate change now. So the way that climate change is addressed is through climate action. And the term climate action officially, according to the UN, has 3 prongs. It means mitigating environmental impacts, so reducing our footprint on the environment, adapting to our environmental changes, becoming more resilient, and thirdly, building knowledge and capacity around climate change so that everyone is able to do steps 1 and 2. And we know that existing buildings have a huge role to play in this. Just between now and 2060, the world is projected to double our existing building stock, which is essentially building a Manhattan every month between now and 2060, which is sort of horrifying. Most of that's going to happen in the global south. But we also know that by retrofitting existing buildings, we can reduce the embodied carbon of construction by 70 to 85%. So this is a real opportunity for advocacy and a real opportunity for existing buildings to contribute positively. And of course, because this is a preservation group, we know it's by no means just about carbon, that the real benefits are in the co-benefits of existing building reuse and heritage reuse. We can preserve cultural identity, we can celebrate histories, we can retain and preserve the knowledge of design and construction from traditional, local, and historic knowledge systems. We can avoid the impacts from new construction. We can improve the resilience of our existing and historic buildings by intervening in them. And we can minimize loss, both physical loss and intangible loss of memory and knowledge. I really like this quote from the Assistant Director General of Culture from UNESCO, that culture is more than just an asset. It's a fundamental resource to respond to the global crisis caused by climate change and biodiversity loss. And this really resonates with me. It's just, how can, and I think part of what has really motivated me in the work I do now is how do we communicate this? How do we communicate the importance of cultural heritage in climate action? And I also want to talk about building reuse as climate justice, because I've talked a lot about carbon, but obviously this is really about people. And we know that that climate justice is a huge issue, that the people who are most impacted by the changing climate and all of the effects resulting from that are those who are least responsible for it. We can see that played out in many ways, such as urban heat island effect. This is just one example where we see levels of air pollution, and on the left-hand side, you see those people who are exposed to high levels of air pollution, and on the right are those who mostly cause air pollution. And you can see again that inverse relationship where the people who are most exposed, most vulnerable to pollution are those who are least responsible for causing it. And then in the box outlined in red here, those are all of the parts of industry that contribute to buildings. And it's most of them. So again, our work as preservationists, as architects, whatever way you work in buildings, has a huge impact on the communities and people all the way up the supply chain, whether you see that directly in your project or not. We also know that demolition is really bad for people in low-income communities. That's where the landfill goes, and that's where the air pollution is going to happen. And so we have to, again, think about retaining buildings as a way to support and make healthier some of the most vulnerable communities. We also know that preservation results in more jobs than demolition and new construction. There are some really great facts from the place economics reports. This one, for example, that reuse and refurbishment produces 300 jobs per 10,000 tons of waste, compared to only 1 to 6 jobs in a traditional landfilling and incineration process. So this is really good, not just for the environment and for culture, but also for local economy. Similarly, total labor income from deconstruction is nearly 4 times that of demolition. So again, when you study it, it's shown over and over that reusing existing buildings, restoring them, salvaging historic materials is better for the economy, and especially better for the local scaled economy. And again, it's important to, I think there's often a perception, at least in Boston where I am, I know in many urban environments, that preservation is sort of an elite concept and that only wealthy people benefit from historic buildings and that that's who they're for, but that's in fact not true at all. And if we look in Boston, you can see on the left our vulnerability mapping based on race and income and age and language availability, et cetera. And on the right, you see the historic districts, and you see the almost direct correlation between the two. So really preserving and taking care of, stewarding historic places is social justice and does promote social equity. And again, going back to this idea of loss and resilience, we know that we're already losing a lot of land, of buildings, of places, and the people on the front lines tend to be more vulnerable communities. And so that is where we need to figure this out. We need to figure it out for those people, and because it's really coming everywhere. So with that, in order to really think about how I could help make this argument of how important existing buildings are, I started implementing life cycle assessment in my work. So I first did this in graduate school, but I came back to it when I went to Goody Clancy to be an architect. And just to make sure we're all speaking the same language here, a few words of terminology. So embodied carbon, again, is that footprint of material manufacturing, transportation, et cetera. Operational carbon is the energy we use to operate buildings. Avoided impacts are the environmental impacts that we avoid by reuse compared to new construction. And then life cycle assessment is a scientific methodology that measures the footprint of materials from cradle to grave over their entire life. So I wanted to apply this to preservation projects, both for decision-making and to really advocate for building reuse. So for example, this is a campus building I worked on that included, it was a study where we were looking at exterior restoration and systems upgrades and envelope upgrades. And so I wanted to understand, is spray foaming this building really the best thing to do for it? So, we looked at insulation options, and this is where I started to look at this concept of carbon payback, which is if you have to spend a certain amount of embodied carbon in order to make a building more efficient, when does that investment pay off? If you think about it as a financial, in financial terms, when does that upfront environmental investment pay back over time? So in this case, we looked at an insulated exterior render. We looked at filling the cavity with cellulose, which actually stores carbon because it's made of a biogenic material, or filling the cavity with spray foam. What we found is that the carbon payback was pretty good for every scenario, because we're in New England and this building was uninsulated. Any insulation was very good. But what we see is this pretty big difference in embodied carbon, and especially with cellulose, where we can actually store carbon. We can draw down carbon from the atmosphere and stick it in the building and keep it there by using natural materials. So that was a big lesson for me. How much time do I have? All right. I then wanted to bring this up to the whole building scale. So this is a historic, much more modern, mid-century historic building, a residence hall designed by CERT, who was a pretty significant mid-century architect in my region. He led the Harvard Graduate School of Design for a while. And so this is a sort of, very typical architectural character for his style. And so the reuse approach for this building was a comprehensive interior renovation and modernization. We replaced all of the windows to match the historic windows. We insulated the exterior walls on the interior face, we insulated the roofs, and we put in all new systems. So we were able to reduce the energy consumption by about 60% from pre-renovation. This also included, obviously, an architectural transformation to really make sure that this building was serving, the next 50 years of students. And what I did on this was the first whole building reuse project for which I completed a whole building LCA. So this is an accounting of all of the material that we added into this building as part of the renovation, how much carbon dioxide equivalents embodied carbon resulted from that renovation. So I used a plugin to Revit called Tally and found that the entire renovation had a carbon footprint of about 780,000 kilograms of carbon dioxide. What does that mean? So first I looked at this compared to new construction. So you can see on the left would be a replacement building in purple in this bar chart, and the green is the renovation. And you can see that across every kind of environmental impact, the renovation results in a huge, 70 to 90% reduction in environmental impact. And if we just look at carbon, the avoided emissions from just reusing the single building are equivalent to growing 133,000 tree seedlings for a decade, or avoiding 13 million miles driven by a passenger vehicle. So this is a pretty big number. And we also know, going back to that time value concept, that we have to reduce emissions in the near term, that one of the most important things about reusing buildings is that it reduces emissions right now in year one. So if we look at the carbon reductions over time, our unrenovated building, if we say year zero is the year of renovation, there are no carbon emissions up front, no embodied carbon, but it uses a lot of energy. So the slope of this line is pretty high for operational emissions. We then look at the renovation. So there's a small amount of embodied carbon up front at year zero, but the slope drops a lot. And that's due to that 60% improvement in operational efficiency that we achieved. So you can see the carbon payback here of only 3 years. So within 3 years, we've saved carbon, total carbon, by reusing this building. Of course, people always say, well, it's better to just tear it down and replace it with high performance new construction. We could make it net zero. So obviously I wanted to explore that as well. You can see that the replacement has a much higher embodied carbon at year zero. It starts at a much higher point. And I gave it an additional boost of 15% energy efficiency just to see what happens. And you can see that even with that lower slope, it takes 30 years for the new construction to make carbon sense compared to that renovation. So that's too late. When we think about that timeline, it's already too late. So that's whole building LCA. That's pretty technical. I'm going to zoom back out, give your brain some space, and talk about some of the work I do outside of my job, because I think for me, I found that this is really where I'm able to connect with my people and get work done that I think reaches more people, more buildings, and has a bigger impact than everything I'm able to do on a day-to-day. So I'm a co-chair of the APT Technical Committee on Sustainable Preservation. If you're part of APT, I highly recommend joining our community. It's really, people are doing really interesting work at this intersection between sustainability and climate and preservation. Based on my participation in the TCSP, I'm one of the founding members of the Zero Net Carbon Collaboration for Historic and Existing Buildings, or the ZNCC. This is also a really great group. The website is znccollaboration.org. And this group is interesting because it's not just preservationists. It's really a group that is, it's a coalition of organizations, including the American Institute of Architects and Architecture 2030 and APT and ECOMOS and the RIIC and the Carbon Leadership Forum and many others who have really come together to talk cross-sectorally around this issue of leveraging the existing and historic built environment. And that all kind of led me to the Climate Heritage Network, which is global. I'm kind of working my way out here. This is a global network at the UN level of organizations all over the world, nonprofits, public sector organizations and ministers, as well as NGOs, universities, et cetera, who are committed to mobilizing arts, culture, and heritage towards climate action. So this is the group that has brought me, allowed me to speak at venues like COP. And it's a really interesting group. I highly recommend checking them out because you get to hear not just about what we're doing locally, but what other groups all around the world are doing, and not just in the built environment, but what are libraries doing? What are museums doing? What role do all of us have to play towards a better climate future? So it's really an inspiring group to participate in. And this is us at the launch. I got to go to Edinburgh for the launch in 2019, and we met in the castle, which was probably the coolest meeting venue I will ever get to participate in my career. It was very exciting. And as you heard, this year I'm chairing the AIA Committee on the Environment. And that's been really interesting to come to, really come back to the architecture side and talk about what the architecture community is doing around existing buildings and building reuse, and how existing buildings are at the cutting edge, the leading edge of sustainability and climate action and climate justice. So this is just one example. The COAT Top 10 Awards are COAT's flagship program. They're considered the highest award you can achieve in the architecture field for sustainable design. And it's been exciting to see more and more existing and historic buildings win this award, not relative to other existing buildings, but relative to all buildings. These can be the most sustainable and the most forward-looking buildings we have. So I'm going to end with some of what I've been doing lately, innovating practice, and talk about the CARE tool. Hopefully some of you maybe are familiar with it, but the CARE tool is a recently launched free online tool, the Carbon Avoided Retrofit Estimator. It was developed by this team of me, Larry Strain of Siegel & Strain out of the Bay Area, an architect, and Aaron McDade with Architecture 2030. And we've been for several years behind the scenes working on this CARE tool, which is an early phase decision-making tool that looks at the total carbon emissions of existing building reuse compared to new construction. So going back to that LCA and how that was really complicated, and I had to have the Revit model, I had to use Tally, I had to do all of that complex modeling. CARE tool is a way to do that really simply and at a very high level without a lot of detailed information to be able to put some sort of number to the benefit of reusing buildings. And it's really meant to be used by a wide variety of people for advocacy, for education, for knowledge building, as well as for early design. And the way it works is you put in some general information about your building, you define the existing building, how big is it, what's its structural typology, et cetera. You input some factors about reuse, how energy efficient is it going to be, and how are you treating the mechanical systems, the structural systems, the envelope, and the interiors, and then what would you be replacing it with for new construction. And essentially you get two charts, one that looks at total carbon for a duration that you set, and then the other looks at those emissions over time, similar to the graph that I showed earlier. So you can say how long you want this analysis time span to be. I'm just going to click through this quickly. It shows you the embodied and operational emissions for each scenario. And then it shows you how those play out over time so that you can make informed choices about when it makes carbon sense to reuse a building and how to reuse it. How energy efficient should it be? How does the grid impact it? A lot of different questions that we have about reuse. So these are some of the questions that can help you answer, that simple question, how much carbon can you avoid by reusing a building? It can help you explore some of the factors that may influence that. What if you can only reduce operational emissions by 50% or by 20%? What if you're in a place with very dirty electricity? Or what if the existing building is falling down and you have to build an entire new structural system? So you can really explore all of these variables. And you can also use it to help demonstrate the importance of building reuse in climate. For example, if you're in a municipality that has carbon neutrality targets, or you're working for a higher education institution that says, I'm going to be net zero by the year 2050. You can use this tool to say, well, reusing this building is going to get you this far towards your goal. That is not decision-making information that most people have at their hands at this moment. So I was going to do a quick case. I'm going to breeze through this. This is my last case study, but this is a research project that I did with Agnes Scott College to use the CARE tool to look at a whole campus. So not just building by building, but really looking at historic campuses. So Agnes Scott is in a historic district outside of Atlanta, Georgia. It's a really architecturally diverse campus. And its historic buildings are really, I think, not surprisingly, fundamental to the identity of the campus and to the sense of loyalty and the sense of belonging that the students and the alumni have. So it's really important. And they've reused buildings a lot over time, and they've shown that you can do it really well. So this is an example of that carbon over time chart, but looking at the fact that we don't just decide one time to reuse a rebuilding or not. Those of us who are in preservation know that that cycle happens over and over and over. The buildings can live hundreds and thousands of years. And so on a typical higher education campus, that cycle is about every 40 to 50 years. So looking at one building here, you can see how that decision to renew or replace happens. In this case, they've renewed this building 3 times. And you can see kind of the carbon savings in green of reusing compared to replacing that grows and grows. The more cycles through which you choose to reinvest. So they have a pretty large range of buildings on campus, but they've mostly been built in different, booms of construction in the 20s and the 50s and in the early 2000s. But they've really they focused on reuse, repurposing, adaptive reuse, moving buildings. Essentially, they've reinvested rather than replaced while they've grown. And so what this analysis was able to show is that this avoided carbon emissions equal to 34,000 metric tons historically. And if you planted their entire Arboretum campus with seedlings, it would take the entire campus 400 years to sequester that much carbon dioxide. So this is really a non-negligible number. And then when we look at moving forward, in 2007, they committed to be carbon neutral by 2037. So if we look at just this period of 30 years they gave themselves 3 decades essentially to get from business as usual to carbon neutral. And if we look at 3 scenarios, the first, where you just tear down every existing building and replace it with near net zero construction. In fact, that only reduces your carbon emissions by 3% during these 3 decades because the embodied carbon is so high. So that's almost a wash, as opposed to this brighter green color, which is both reusing buildings and also renovating them and retrofitting them. For example, installing LED light bulbs and retro commissioning HVAC systems and working with occupants to really change their behavior to use less energy. This results in a saving of 41%. So it's really clear that in order to meet their carbon neutrality goals, building reuse must be an important strategy. And so they've taken this and been able to use it to help fundraise, to help promote their historic buildings, not just from a heritage and a cultural standpoint, but also as part of their environmental and resilience goals. So it was really, that was an exciting one. So I'm going to leave it with what I'm doing now. I'm at Northeastern experimenting with teaching and research and really just taking a break from practice and thinking a little bit more freely. I'm also consulting with the Cameron McAllister Group, which is more business consulting. So helping firms not think about how to make sustainable buildings, but think about how to arrange their practice in a way that fosters sustainability and fosters equity and inclusiveness within their firm, thinking about strategic planning and how this can all be kind of organizationally implemented. I'm doing obviously more work on the CARE tool, and I've also been enjoying just experimenting and exploring all of the opportunities. So for example, I'm working on a grant in the Boston area that's trying to figure out how to decarbonize our supply chain around concrete, which is one of our biggest emitters, one of the biggest emitters. So really just trying out all of these opportunities that are available. So I just want to end by coming back to my roots here and historic buildings. And I think if there's one thing to take away, it's really just that these buildings and the knowledge within them and the connection they make us feel to place is so important. And when we look at how we can both preserve them and also how we can learn from them and infuse that into new construction and really reflect sense of place, sense of environment and vernacular knowledge, I think I see a lot of hope for the future of the built environment. So I'm going to end there. Stop sharing.
Thank you so much, Lori. That was so interesting. We have a lot of work to do in Arkansas on this topic, I will tell you that. Okay, you've got a long question from Aaron Ruby. If we can see the writing on the wall that we will not meet our climate goals and therefore sea levels will rise, and of course, we as preservationists care very much about historic sites and places in coastal communities, is there any talk about massive seawall projects instead of doing the work like you showed with the example about raising the building?
Yes, I mean, there is, for example, in New York and Manhattan, they're talking about a seawall around the entire south edge of Manhattan. I think Boston is looking at seawalls. I think many places are looking at seawalls. And I think, what I took away from, well, it's a lot of things. What I took away from that 74 Bridge Street study is that it's not a either or. I think it has to be a collaboration at all levels. And obviously we have to think at the infrastructure level. There are some pretty, entertaining pictures of buildings that just like build a giant mound and sit on a hill, or that build a giant moat, and isolate a single building. And we know that that's not how we're going to solve the problem. I think the risk with things like seawalls is like the levee, that they're a guess. Firstly, we don't know how much water they're actually going to have to restrain, hold back. And then also they can fail. So what happens when they fail? And that's, so I think it's, it's both and. I think almost everywhere is looking at those types of engineered solutions. There are also some really fascinating nature-based solutions, which don't protect, don't stop inundation from happening, but they do provide a buffer. So looking at naturally, plantings that can absorb water quickly, most of which are restorative to local habitats that were there before development, are also, part of that holistic solution.
Thank you. Okay, there's something in the Q&A. Okay. You left us with 2 takeaways. Building reuse is climate action, and then what are we leaving behind? Thank you for this inspiring talk. Okay, on historic buildings, do you typically replace windows or keep existing? I ask because double pane windows have a useful life before the seals begin to break down. Do you have a source for single pane windows? And I was going to ask you about windows whenever you mentioned in the residence hall project that the windows are replaced. I was like, what?
I know. No, people hate that. Yeah. I do not advocate for replacing windows. I feel like I should have like a disclaimer on that project, that I think I have. When I showed that study I did of the insulation options, we also did a study of, is it best to keep the existing windows or replace them with double glazed or replace them with triple glazed? And what I have found many times, like over and over, is that in my climate, depending on the use type, it doesn't make sense from a carbon perspective to replace windows for many reasons. One, if the biggest loss of energy can be just from infiltration. So I think everyone in preservation knows that if you restore a window, you reglaze it properly, you repair the joints, you can get a pretty tight window. So that's effective for very low embodied carbon. The replacement cycle is also really important. this is like one of my pet peeves with owners, that they're like, well, I just want a new window because it's going to work better. And it's like, it will work better for about 7 years, and then it will work worse, and then you will have to throw it away. So I think it's a one-off, every project is going to have a different answer. And on the one where we replaced those windows, they were already aluminum windows that were hard to repair. Or add a storm. Yes, thank you. Yes, add a storm window. That is also restoration plus storm has been shown to perform the same as double glazed. So absolutely. I'm ranting now, but yes, no, I think it's important. It's an important, the embodied carbon argument has been very helpful in having that conversation with owners.
Thank you. I thought it was interesting. You mentioned deconstruction, and that's obviously, where you would go, what you would want people to do if the building couldn't be saved, or it just was not going to be saved for whatever reason. I'm not aware of any major deconstruction efforts in Arkansas. Do you know if that's common? Like, are there certain parts of the country where is it concentrated in certain areas? Do you know if the deconstruction industry is just like taking a while to work its way
I think
to us?
a lot of growth in the past 3 years even. And I think this is one of those areas where regulation plays a huge role. For example, Portland, Oregon has a deconstruction ordinance. And so there's a big salvage economy built around that because it's required. Similarly, I think, the city of San Antonio, which is not that far from Arkansas, relative to the scale of things, has a deconstruction program now through the Office of Historic Preservation, which is really exciting. So I think policy is helping to drive that. And I also think that there is a more robust marketplace forming, that there are now tools online that are helping, people are making platforms that help connect people who need materials to available materials. And I think that's helping to overcome another big part of the salvage and deconstruction problem, which is, what do you do with the materials? How do you know where to find them? And how do you, get them from point A to point B? So I don't know, it's been slow to pick up, but I think that the new regulations and the kind of improved economic viability is starting to get better. I don't know of anything specifically in Arkansas.
But that's helpful insight, because that lets me know that essentially all hope is not lost if it's not done on the statewide level, that it's more of a local ordinance could help encourage that, as it does in the city of San Antonio.
Yeah, I think so. And even in the city of Boston, we don't have any policy about it, but we have done a pilot program. So that's a pilot building where it's actually the waste office within the city has partnered with some commercial real estate developers and some other salvage organizations, advocacy organizations, and nonprofits to just test this out on a couple of buildings. So even that kind of demonstration project, I think, can have a huge impact.
Mm-hmm. Thank you. Okay, do you have a favorite project or a project that you've worked on that you feel is like the most impactful thing that you've done so far?
I think the CARE tool has to be the most impactful thing I've done, and I came to it really by happenstance. But I think that's why I really enjoy working outside of my day job, because I think when you can do things like this and talk to people like you, and talk to people outside of your normal sphere and create tools and resources that really anyone can pick up and use, that is, to me, where the big impact. I feel like I've been able to make a bigger impact than I would ever have as just an architect working building by building.
Thank you. How do you have any suggestions, wisdom, strategies for how people can try to encourage and advocate for this issue whenever it can be a politically divisive topic in some places, and that's community by community, really. Mm-hmm. But do you have any advice on that?
Yeah, I mean, it's easier said than done, but I think my advice is really about going back to those co-benefits of preservation and understanding what is important to people in a local community. And maybe it is that idea of local jobs that you can create a lot of local jobs and, you know, workforce development programs by teaching people how to restore and maintain buildings. Or maybe it is, you know, at something like maybe it's about air quality, and maybe it's like we just want to have healthy air for people. And, you know, so I think there are different angles. There are so many benefits to building reuse that for me, it's about finding what's going to resonate with the people you're talking to. And often that's economically driven.
Yes, it is. Okay, there's something else in the Q&A. Some compliments to you. Bravo to you for the work you're doing. Your career journey is inspirational in support of renewing existing buildings. Hey, I don't see any other questions or comments besides compliments on your talk. So Lori, thank you so much for speaking. I really appreciate it. I think it was an enlightening presentation.
Thanks so much for having me.
Thank you. Bye, everybody.